Hello learners, this is Dr. Fatima presenting you the data structure. Let us see in this video the list, that is the array and the linked list, types of linked list and the single linked list in detail. Coming to the list ADT, it can be represented in two ways as array and the linked list. The operation that can be performed on these ADT are insert, delete and search. Let us see the array ADT. Array is a collection of elements of similar data type. Elements in an array is stored in adjacent memory location. The syntax for declaring an array is data type, array name and the size to be specified. In this example, an array A is of data type int with a size 6. The operations like insertion, deletion and search can be performed in this array. Everything put together is called as an array ADT. Let us see the drawbacks of an array. Consider the example array which consists of the elements 10, 30, 45, 60, 78 and 99 in array indexes 1, 2, 3, 4, 5 and 6 respectively. Once the array is declared, it is of fixed size. Later in future, if the array is to be extended, then resizing is expensive. Similarly, for meeting the future requirement, if the array size is declared as maximum size, then it will lead to wastage of memory space. Array requires continuous memory for allocation, which is very difficult when the array size is larger. One more drawback is the insertion and deletions are inefficient in arrays. Consider, for example, if an element 40 is to be inserted at the array index 3, then the elements 45, 60, 78 has to be shifted to the array indexes 4, 5 and 6 respectively. Now let us see about the linked list. Linked list is a linear data structure. It is a collection of nodes linked as a chain. Each node contains a data and a pointer to the next node in the chain. The elements in the list are not stored at continuous memory location. The first node is called as head and the last node is called as the tail. The last node of the list is pointed to null. This slide gives you a visualization of a linked list. Let us see how the nodes in the linked list is represented. Each node contains two fields. One is the data field which contains the data element to be stored. The other one is pointer field which contains the address of the next node. Both data field and the pointer field put together is called as a node. This diagram shows you the example of a linked list. Here, the head element contains the data field 30 and the link field the address of the next node, which is 1015. Similarly, the second node contains the address of the tail node. Now let us see how the node is declared and created. The declaration of a node is done using the data type struct. Here, the struct node consists of two elements. One is the data, which is of data type int. The other one is the next field, which is of data type struct node. Then we will see the creation of a node. Here, a new node n is created using the data type struct node. Then the memory is allocated for this new node using the malloc function. Then the next field of n is set to null. Let us see the types of linked list. It is of three types. One is singly linked list where the nodes are linked forward only. The next one is doubly linked list where the nodes are linked both forward and backward. The next one is circular linked list where the last node is linked to the first node as next and the first node is linked to the last node as previous. Let us see singly linked list in detail. Each node in the singly linked list contains one pointer field that contains the address of the next node in the list. The operations that can be performed on the singly linked list are insertion, deletion, and search. Coming to the insertion, there are three possibilities where the insertion can be done at the beginning, at the middle, or at the end. Similarly, the deletion can be done at the beginning, at the middle, or at the end. Let us see the insertion of a node at the beginning of the list. The first case is the insertion can be done in the empty list. Consider n be the new node to be inserted. The first step is to create a new node by setting the data and the next field. Here the data field is set to n, 10 and the next field is set to null. This is how a new node is created. Since there are no other node in the list, we have to set the head as well as the tail. So head is set to n and tail is also set to n. Next we will see how the insertion of a new node is done at the beginning of an existing list. Consider the example of list shown in the slide. Let n be the new node to be inserted. Create a new node and set the data and the next field. This new node's pointer has to be linked to the head in order to make insertion at the beginning of the list. This is done by setting the next field of n to head. By this, the pointer field of n will contain the address of head. Now, the new head will be set as n. So the whole head will disappear. Let us see the insertion at the end of the list. Consider the existing list and n be the new node to be inserted. As usual, we will create a new node that will be the first step. Since the insertion is done at the end of the list, we have to set the tail. So now the tail node will have the link field set to null. This tail node has to be linked to the new node by setting tail.next is equal to n, by which the address field of the tail will contain the address of the new node. Now the new node will be set as the tail node by setting tail is equal to n. Let us see how the insertion is done in the middle of the list. Consider the new node to be inserted is after the 60. As usual, create a new node by setting the data and the next field. We'll make use of a pointer p which is pointing to the head initially. The p will be traversing through the list until it reaches the node which has the value 60. Now the pointer field of this node p has to be changed by setting the next field of n to point to the next field of p. Then the next field of p is made to point to n. So the link between p and tail disappears in this example, and the new node n is inserted in between p and the tail. Now let us see how the deletion is done at the beginning of the list. Again consider the existing list Since we are going to delete the head node, set the head to be head.next and the link of the old head node disappears. Next, let us see how the deletion is done at the end of the list. Consider a pointer P initially pointing to the head, and this pointer will be traversing till it reaches the tail node. Now set the new tail. P.next is equal to tail. Once the node before the tail is reached, we are going to set P.next is equal to null. Then the link between the P and the tail disappears and we have to set a new tail, that is tail is equal to P. By this, the deletion will be done at the end of the list. Next, let us see how the deletion is done at the middle of the list. Consider n is equal to 10 be the node to be deleted. Consider a node pointer P pointing to the head. And we make use of one more pointer Q which is pointing to the next field of P. These P and Q pointers will be traversing through the list until it reaches the node which is to be deleted. Once the node is reached, we have to set the link field of P to point to the link of Q. That is done by P.next is equal to Q.next. Now the link between P and Q disappears. That's how the node 10 gets deleted from the list. Let us see how to perform the search operation in the list. Let n be the data to be searched. Consider a pointer P pointing initially to the head node. This pointer has to traverse through the list until it searches the data element given. Once the data found, then it will print the data found, else it traverses through the list until the tail. I hope you enjoyed this video. Have a happy learning.